to look at the length, midpoint, and gradient of an interval. So with an interval, here we've got the Cartesian plane. We've got a position on the left, x1, y1, a position on the right, x2, y2. Okay, so if we're looking at this distance here, we can use Pythagoras' theorem. All right, so we've got a squared plus b squared equals c squared. That's the basis of it, of course. So if we look at this length here, because this is a height of y2 take y1, so you can see that the y2 figure just runs into there, the y1 figure runs into here, so that distance that's from here to here is simply y2 take away y1. Same thing applies for this distance. Okay, you can see that it's going to be x2 take away x1, so x2 runs to here, so it's x2 take away x1. And so now I'm able to apply Pythagoras' theorem and go the hypotenuse will equal the square root of x2 take x1 all squared plus y2 take y1 all squared. And of course the hypotenuse is that distance. Here we have a problem. Find the distance between these 2 points. And I just think of the first point as being x1, y1, the second point as being x2, y2, and I sub those into the rule here. And you can see it's direct substitution, and there's my answer. Of course, if I had my CAS calculator, there'd be nothing stopping me, as far as my workings are concerned, is stating the rule, having the correct substitution in, and then provide your numerical answer that you're looking for. You don't have to have these working steps in between. Here we have an application where we have to work out the distance between the points A and B. So obviously some kind of hiker. We've got a position A, which is west 12, south 5, and a position B, which is east 7, north 4. So if I think of the Cartesian plane with my reference point here, that's being 0, 0, values to the east are like the x values and positive, values to the west are x values that are negative, positive y values, negative y values. So we just want to convert points A and B to points in the Cartesian plane, i.e. in terms of x and y. So A will become negative 12, negative 5, and B will become 7, 4. We've got our D rule, and I just do my substitution into it to produce a square root of 442, which represents 21.02 kilometers. So the distance between points A and B is 21.02 k's. We can also work out the midpoint. So if I've got point A and that's x1, y1, B is x2, y2, the midpoint is just going to be halfway between the length of the x's and halfway between the y's. That there will represent the midpoint. So to work out the x value for the midpoint, I add the two x values together and divide by 2. Same thing with the y's. In problem 3, I need to locate the midpoint of the segment joining 5, 9 and negative 3, 11. So segment just means a straight line joining them. So here's my rule. I've got correct substitution, and then there's my answer, 1, 10. Again, this is just a working step, not necessary to show. We know a fair bit about gradient already. Remember that the gradient is simply a measure of how steep a straight line is. To calculate the gradient, we just need 2 points that are on that line. The first point we call x1, y1. The second point we refer to as being x2, y2. Then we can apply this rule. M is equal to y2 take y1 over x2 take x1. We can also relate that to an angle, which I'll explain in the second question here. Remember, positive gradients go up towards the right. Negative gradients go down towards the right. Problem 4, what is the slope of the line joining these 2 points? So again, I refer to this first point as being x1, y1. and the second point is being x2, y2. Here's my rule, y2 take y1, so I want 5 take away 3, and then x2 take x1, I want 4 take away -2, and that will become 1/3. In problem 5, what angle does the line passing through -2, 8 and 1, 2 make with the positive axes? This is going to be based on this fact here. The gradient will equal tan theta. Right? That's the underlying principle behind this. So, with those two given points, I can easily calculate the gradient. So the gradient is equal to -2. Remember, it's a measure of steepness. So for every one step I take along the x-axis, I'll go down 2 steps along the y. So the gradient is equal to -2. So I substitute -2 in for this rule here. So -2 is equal to tan theta, where theta is unknown. And I can solve for theta. So I can do that in two ways. I can just go menu, algebra, solve, and put in the equation and solve for x or theta to spit out an answer. Or I can just go, let's strip this equation back so I get theta by itself. So I'll do inverse tan of both sides, and so I evaluate what inverse tan of -2 is. Now you remember a little bit from circular functions last year that possibly this could produce an infinite number of restrictions, because with the unit circle we keep on turning around and around and around an infinite number of times, meaning that an equation like this will have an infinite number of solutions. But what we can do when we use a solve is put a domain restriction in place. So here we're putting in the line, and we've got -2 equals tan of x comma x, given that x is between 0 and 180 degrees. Okay, so you need to make sure that your calculator is in degrees, and you put that domain restriction in, and it'll produce that theta is equal to 116.57. Now when we look at this, we know that we have a negative gradient. So we're expecting that if we drew the x-axis, that the straight line passing through it should be going down towards the right, so I'll draw it like so. And then the 116.57, the angle is always referring to the positive part of the x-axis. So the angle could be in here, or it could be in here. It can never be to the left-hand side because that's the negative part of the x-axis. So this is the positive part, referring that way. So the 116.57, it could go in this part, down below, or above. But it's always going to be above because this number here, 116, is greater than a right angle. If the angle that we received or calculated as an answer was less than 90 degrees, and this is the diagram that we had, then it would be in here. Alright, so let's take a look at the second bit of theory now. If we look at this diagram, we've got an angle theta in here. This angle theta is exactly the same as the angle in here. Now we know that the gradient m is equal to rise on run. So we have our rise over our run. This is the angle theta in here as well. And we know that if we take tan of that angle, it will equal opposite over adjacent. So what we're seeing here is that both the gradient and tan of that angle are equal to rise over run. So what we can say is that the gradient, m, is equal to tan theta. And we can apply that to situations such as question 5. What angle does a line passing through these 2 points make with the positive x-axis? So when we're talking about the positive x-axis, we're talking about to the right-hand side here in the positive direction, not to the left. Well, firstly, we know that we can calculate the gradient from these 2 points. y2 take y1 over x2 take x1, and we get a gradient of -2. Here's our major rule. The gradient is equal to tan theta, where theta is the angle that the line makes with the positive part of the x-axis. So it becomes pretty simple. I just need to solve this equation. And if I do so, I'll get theta equaling 116.57. Remember that this gradient was -2, so the line would go down towards the right. And it's all making sense because you can see that this angle with a negative gradient, it's got to be greater than 90 degrees, and this has got to be less. And this is the angle, or this is where we place the angle that we get from our calculation in the positive part of the x-axis. So 116.57 goes here. Now when you go to solve this equation, you do it on your CAS. If you don't put a domain restriction in, you're going to get an infinite number of solutions. Now, remember last year when you did circular functions, you realized that there are an infinite number of solutions for trig equations. And the reason being is that you can go around the unit circle an infinite number of times. Let's take a look at our CAS.